Fourier transforms. So this can be categorized in sort of the random bucket. This isn't terribly related to what we do every day, but it was something I did and it was fun, and I just wanted to share it. So, uh, as a hobby, I'm kind of a math nerd. There's a YouTube channel called 3 Blue 1 Brown, which is if you're into math at all, it's a really cool channel to watch. And one of the subjects was Fourier transforms, and the whole point of the channel is to, like, in a really visual way, explain a math concept. And so I watched the one on Fourier transforms, and it introduced this, and it had some recommended blog posts. And so I'll just briefly introduce it and then show you a small thing I did. So what is a Fourier transform? A Fourier transform is basically the process of taking a signal or a function, a mathematical signal over time. So for example, this could be like a sound wave, and taking that signal and asking the question, can you break this signal down into a series of different sine waves? This can be useful for various things. So if you look at the above signal that we were looking at, it can be decomposed into two different sine waves that have that shape and frequency. So that's kind of neat. This is the other typical hello world example, is taking a step function that alternates between 1 and 0 or 1 and -1, and approximating that with sine waves. It's also possible, but it takes a lot, and you actually will never approximate it 100%, but as the number of approximations approaches infinity, you'll get closer and closer to a perfect approximation. So that's kind of cool, still kind of boring, still makes people yawn. So what's the cool part about this? Well, you can actually consider other types of signals. So here's sort of I guess this is a demonstration that this actually works on any arbitrary signal. So I can just make this as jaggedy as I want, and it'll produce a series of sine waves that approximates it. The cool part is if you introduce, if you represent the signal as complex numbers, which I'm not going to explain what that is in this talk, but what that allows you to do is something like this. This is sort of the same thing. These are still sine waves, technically speaking, but the signal here is a series of points that have 2 dimensions that you can traverse over time. And so there is some math that you can use to actually compute the sine waves. This is just a different representation or visualization of sine waves. And you can trace it out. So I looked at that and I was like, that's really cool. Like, way too cool than what it should be. Like, I got really excited about it for no reason, but I was like, I bet I could do that. So I searched around for how to implement it in code, and I found a few implementations. I decided to write my own. I'll blow this up a little bit. And so this is what you just saw on the other screen. Right now I default to showing a square, but if I, for example, draw out a triangle, it'll consider that series of points as a signal over time. It'll do some math on it and come up with the approximation of sine waves, here represented by rotating circles, that traces out that signal. And again, it's any arbitrary shape. So if I make like I don't know, a happy face, this is going to be really ugly. So you're going to see how bad my artistic skills are. Again, it's treating this as a signal, and it's going to try and approximate it as best as it can using sine waves. So I thought that was really cool, and so I decided to do it. I think this is the blog post that has an interesting thing at the bottom here. Maybe not. One of these blog posts I came across, it basically traced out, here it is, the text. It traces out text, and I thought, that might be cool sort of as in a presentation for animating a slide, or just introducing a new topic, maybe speed up the animation quite a bit. But again, anything where you have a series of points over time, it can be approximated. So that's all I wanted to share, and that's my presentation. Thanks.